Rohit, how many types of architecture we have seen in the last class?
There are two types of.
2 types or 3 types we have seen in the last class? Okay, what are the 2 types
There
of
are
those
two types.
architectures?
Yeah, source to target
Okay, source to targets.
and general reports for analysis purpose.
No, that is the complete system, right? We have seen 3 architectures. So source to direct warehouse, source to staging area,
Where,
staging area to
yeah,
warehouse. Okay,
yeah,
and
yeah.
source to staging area to warehouse, and warehouse to data mart.
Data mart.
Right?
Yeah.
So now, Praneeth, what is the difference between data warehouse and data mart? Praneeth, what is the difference between data warehouse and data mart?
Data warehouse consists of is a structured repository.
Data warehouse, right?
Yeah.
Then, okay. What is the data mart? What is the difference between data mart and data warehouse?
Data mart is a place of non-volatile and integrated data.
Data warehouse is also non-volatile integrated data. Data warehouse is also non-volatile and integrated data. Data warehouse is also non-volatile and warehouse. But what is the difference between data warehouse and data mart? Right. So we have like a 3 types of architecture we have seen. Okay. Praneeth. Sachin, Shalini and Harita and Shiva. So what is the Rajkumar? What is the basic difference between data warehouse and data mart? What is the basic difference between data warehouse and data mart? Please let me know. Data mart also contains all the data with including historical data. Okay, the data mart, data warehouse contains all the data which include historical data. Yes, the data warehouse contains the entire organization's data. So the data warehouse, okay, this is the data warehouse. This part, whatever part here I have, okay, see this is the center part, the warehouse, okay. This warehouse contains the complete data of your organization. In the last class, we have seen, okay, so GE, for example, General Electrical, GE contains the different business units, manufacturing unit, financial unit, and corporate unit. 3 different units, or more than 3 units also. It contains any number of unit. So the GE warehouse is an enterprise warehouse. Enterprise warehouse means it contains the data from all the business units. It contains the whole business units data. It's a complete warehouse. So the data mart is the subset of data warehouse which belongs to a specific unit, like a purchasing department or a sales department or inventory department. Okay, so here in this diagram, so there is no data mart. So in this way we can create only warehouse without any diagram, without any data mart, business specific data. So here we can further create a data mart which is a subset of your warehouse where the people can generate a report from that particular business unit only. Okay, that's why we have seen 3 types of architectures. One is, so the simple base source to warehouse directly, source to staging area to warehouse, and from the warehouse end users will do the reporting. So this part, generating reporting part, is called as a online analytical processing. Up to here, This is called as a loading data into warehouse. Warehouse is nothing but a database. It contains a tables. Those tables will load the data from sources, different sources. Okay, so DW architecture with staging area, warehouse and data mart. So from the data mart, end users will be generating a report. Okay, everybody. So let's see. Now here, okay, see here, from the data warehouse to data mart, we have already seen here. From this warehouse, we will be loading the data into this warehouse. From this warehouse, the data will be loading into this data marts. Okay, so now the data warehouses can be developed in two ways. Two methods of data warehouse development. So one is the top-down approach and bottom-up approach. Top-down approach. The top-down approach means here in this top-down approach, first we develop enterprise warehouse. First we will develop enterprise warehouse. So then data marts will be developed. Okay, so then data mart developed. First warehouse, then data marts. So in the bottom-up approach, first, so we develop data mart. So then from all the data marts combinedly generates into the enterprise warehouse. We can use the best way. So most of the people will follow this approach. First, people will load the data into warehouse, enterprise warehouse. So then it loads to data mart. First loads to warehouse and then data mart. Here, the first we will develop into the data mart, then warehouse. So the top-down approach and then the bottom-up approach. Okay, so the top-down approach and the bottom-up approach. See here, first we will develop these warehouses, the data mart and then warehouse. This is called as a bottom-up approach. So or we can do the data warehouse, then data marts. Either way we can, it is possible. Okay, so now what is the difference between data warehouse and data mart? Okay, so the scope of data warehouse is complete enterprise wise, complete enterprise data. So the data mart is a department specific. It's a subject to a particular department. Okay, here the subject is multiple subjects. Why I'm saying it is the multiple subject is, okay, I can have manufacturing subject information, I can have financial information subject, or I can have the corporate information. So three information. But so the data mart is the single subject. Only the data belongs to financial. So only data belongs to particular department. So that means corporate department. So the amount of data is a subset. So the data sources. So what are the sources to feed into data warehouse? Many sources. That means the data. So here, so the GE warehouse which receives data from all the departments. Manufacturing department sources and financial department sources and corporate sources. So the number of sources from where we are loading the data from warehouse into warehouse is a many in the warehouse. While specific to the data mart is the few. That means the sources belongs to particular business unit. The data mart loads the data from the sources belongs to particular department. The size, okay, the size is it's a greater than 100 GB and greater than 1 terabyte also. That means the size of a enterprise warehouse is huge when compared to the size of data mart. The size of data warehouse is huge when compared to the size of data mart, because the data mart is the specific to particular department. Okay, so now here, how much time to take to develop a warehouse and how much time to take to a data mart. So the data mart is only few months and the data warehouse is a few years. So months to year, that means 1 year or 2 years or 3 years. Okay, everybody. Everybody is a clear understands between the data warehouse and the data mart. Everybody is a clear, please. Response is required. Okay.
Yes.
Now let's see. Okay. So now we're going to see some important steps here. Yes. So this is the data warehousing architecture. Okay. Please observe carefully. So what are we going to do? So as a okay, so now the data warehousing architecture is very important. The data warehousing architecture. See, this relational databases, legacy data, and purchased data. So these are the three different sources. So first thing in a warehouse development is three sources we need to identify. What are the basic in the warehouse? Okay, first DWH architecture and data flow. So how the data flows in a data warehouse? First, sources. So the sources from where, so we will be extracting data. We will be extracting data and loading into warehouse. So the warehouse is also a table. So the warehouse. So these sources can be anything. Sources can be anything. Can be anything like RDBMS, SQL Server database, for example. It can be a Oracle database. It can be a SQL Server database. It can be a Teradata, a source to a warehouse, and it can be a flat file, text files, and CSV files, and XML files, and anything. So the sources. Okay, first thing is we need to identify the what are the sources. What are the sources of your system? Now, so from these sources we are extracting the data. So after source identification, so the next step is to extraction and cleaning the data before loading. So after extracting data from source, okay, so we need to clean the data, clean and transform before loading into warehouse. So we need to convert the data because as we have a different sources. See, these are the three different sources: relational databases, legacy data, purchased data. The format of three sources can be different. But here in this diagram, in the warehouse, in the data warehousing engine, so we are going to store the data in a common form between these three sources. So because the three different sources have a three different format of the data. So but warehouse is going to have a single format. That means all three sources can be transformed into single form. So that we will design the warehouse. So the extraction and cleaning the data. We don't want to load unnecessary data into my warehouse. Then cleaning and transform the data and load into warehouse. So how we are going to load? Using some kind of loader methodologies. Okay, what is this loader? What are the tools we are going to use and what are the reporting and everything we will see. And then now, okay, so once the data is loaded into warehouse, so we will generate a report. So the reports can be any type of report. So once data loaded into warehouse, So the warehouse is nothing but a table. Warehouse is nothing but the target database. When the data loaded into warehouse, so the reporting team, OLAP in the sense is online analytical processing team, generates multiple reports as per requirement. Okay, so now as per the requirement. Now, so here, so now, okay, sorry. So now here, see, this is a metadata repository. So this is the, see here, metadata repository. What is this metadata repository? So now, see here, what is this ETL? So this is extracting from the sources, and we are doing the transformation and the loading. So this extraction, transformation and loading, and then reports generation. So we need to write some kind of coding, or we need to develop some mappings, okay, or we need to develop some transformations. What is the role of this mapping, what is the role of this extraction, and what is the role of this transformations? So the extraction job, whatever we are doing the extraction, that extraction purpose is to extract data from the sources and load into warehouse or staging area. So now, from where we need to extract, from where to load, and what are the transformations we load, and what are the business logic, what are the cleaning rules. So all these rules, okay, your coding, how we are going to extract, how we are going to apply the rules, how we are going to apply the filter, all these definitions. So the way, okay, so the coding or the mapping development will be stored in this metadata repository. In your computer terminology, the data what we are using for this extraction purpose, the data what we are using for this extraction and cleaning and transformations and repository. So our coding stuff, it can be a OBI reporting tool, or it can be a business object, or it can be a Informatica, or it can be a ODI, or it can be a OWB, any tool for any report. We develop something to load the data from end to end. Using Informatica, we will develop a maps that loads data from source to target. Using ODI, we will develop an interface which loads the data from source to warehouse. Using OBIEE, we will report from target to report generation. So these are all the different tools we will use for loading the data into warehouse and generating the report. Okay, the tool, what we are going to use the tool to develop the software or to maps, where we store that maps. Those maps definition will store in this metadata repository. So the repository in any tool, any ETL tool or any reporting tool. So the repository, what does the repository contains? Repository contains the logic for extraction, transformation and loading. Everybody is clear? This is very important. Everybody is clear the way data flows and the importance of the repository. We need to identify what are the sources, we need to identify what is the target, and we need to identify how we are extracting the data, and what we are doing for the data cleaning, and what we are doing for the data manipulation operations before loading into the warehouse. Everybody is clear? Everybody is clear? Yes or no, please? I want yes or no.
Yes, sir.
Okay, super. Now, see here, this is the more detailed architecture. Okay, this source systems. The source systems can be a CRM or ERP or legacy or e-commerce applications. Okay, so the sample technologies, it can be a PeopleSoft, it can be a SAP, CBEL, Oracle applications, or any custom system. See here, these are all the source systems. Okay, so this is the area where we are going to have a ETL area. So what is this ETL area will do? So ETL stands for extraction, transformation and loading. Okay, it cleans the data, it filters the data, it standardizes, it decode, apply the business logic and deduplicate the records and merging the records. These are all the operations or transformations we will apply on extracted data from the sources. Okay, what are the ETL tools we have? Informatica, ETI, Oracle Warehouse Builder, and a custom programs or SQL scripts or ODI. ODI Kettle or any IBM data stage or Ab initio. And I can write my own code using the PL SQL ETL layer. So this is the ETL layer. So now, so once this ETL layer, it extracts the data from the sources. This ETL layer, it extracts the data from these sources. I do all these transformations, standardize the data, and load into this warehouse. And load into this warehouse. Into warehouse. So now from this warehouse, it loads into different data marts. Okay, so now what is this metadata repository? Metadata repository is your the component, or it's a different schema where we are going to store your the definitions of the source and the rules and what is your component we are developing and everything using your metadata repository. Okay, so now from the data warehouse using the presentation layer, this is called as a OLAP layer. So we will develop the reporting tools. See here, custom tools, HTML reports, Cognos, business objects, MicroStrategy, Oracle Discoverer, and Brio data mining tools and portals or OBIEE, business objects, Crystal reports, or anything or any reporting tool which generates a report. Everybody is clear with this diagram?
Yes, sir.
Okay, so now we have seen this from the data warehouse to data mart. Okay, this is the way we have already seen this one. First we will develop the warehouse, and then we will divide into different departments, and then we will individually structure. This is called as the data marts. This is, we have seen the data warehouse and the data mart definition, and dependent and independent data mart. That's not a big deal here. And yes, see here. Data warehousing terminology. So the source data, what is the data, what is the important terms into the data warehousing terminology? Important terms. So what are the important tools in the data warehousing terminology? Okay, first thing is the source data, source system and the data. Okay, the source systems, what are the sources and from where we are extracting the data and what is the type of data in the source system. Okay, technology of the source. Technology of source and format of the source data. This is the thing we need to identify, source system and data. Okay, see here, this is your source data. Okay, the data integration. The data integration means, and the second step is that data integration. Integration. So the data integration means it's a ETL layer. The data integration means ETL layer. ETL layer is responsible for loading, extraction, transformation, and layer definition. Extraction, transformation, and loading. Transform. And we are loading into this enterprise warehouse. Enterprise warehouse. And then the data marts. The data marts are optional. Okay, if it is only the big warehouse, then we will do the data marts. Otherwise, they can generate the reports. And then OLAP reporting, or some people use it to call as a business intelligence. Business intelligence. So the generating a reports. Okay, business intelligence. So these 5 components are called as a this complete data warehousing terminology. Okay, So now the data warehousing approaches are bottom up approach and the top down approach. We have seen this one. Okay, now let's see. So what I told in this one, the data warehouse. So the data warehouse is nothing but a, yes, see here. Okay, this is the diagram. Okay, let's see. First we will see this one. This is the diagram. Okay, so now here these are the three different sources we have: operational system, and flat files. Let's consider from these sources. First we will extract the data and load into the staging area. Perfect. So from this staging area we will load into this warehouse. Okay, so generally what is in a warehouse? Okay, the warehouse is nothing but a database. Data warehouse. So, okay, the data warehouse is nothing but a database. Data warehouse is nothing but a database. The database contains the database. It contains all historical data. This database contains all historical data. So it has some characteristics: subject oriented, okay, non-volatile, subject oriented, non-volatile, and time variant. And what is the fourth one? What is the fourth characteristic? Subject oriented,
Integrated.
and integrated.
Integrated.
Integrated data. So these are the four characteristics. Okay, the data warehouse. Okay, so now, so using ETL, extract from source. Okay, transform extracted data. So then loading into warehouse, right? So loading into warehouse. So this warehouse is nothing but a database. That database contains a set of tables. Warehouse is nothing but collection of tables. So we will load the data. So now what is the technique? So we need to design the tables. Okay, we need to design the tables for loading the data. Right. So how we are going to technique for designing the data warehousing tables or method, modeling technique. Technique used for DWH development. See, we cannot create tables blindly. We need to follow some kind of methodologies. We need to modeling technique used for data warehousing development. So here we are going to use a model called dimensional model technique. Dimensional data model technique. So dimensional data modeling technique. You will be used dimensional modeling technique for designing DWH tables. Okay, so now we have two types of applications: OLTP applications and DSS applications. For OLTP techniques, we will use ER modeling, entity relationship modeling, and for DSS and DWH, we will use dimensional model technique. We will use either ER modeling or we will use decision support system. So the dimensional modeling technique. Okay, so both contains the tables. In the ER modeling also, online transactional system also, it contains the tables. But DSS tables also, it contains the technique. Tables only. But the way we organize the tables in both techniques are little bit different. See, ER modeling, your source system also contains the tables, but in the warehouse also contains the tables. But the number of tables, the way we organize the tables in both Entity relation table and dimensional modeling technique are completely different. Okay, so now in the ER modeling, complete modeling, we are going to have a more number of tables. So more number of tables, normalized tables, more number of normalized tables. Here less number of tables, very less number of tables. Why we are going to have a less number of tables? What is the advantage? Okay, so the data warehouse contains huge amount of data, it's a billions, in the terabytes of data is going to store in a database. If we store that much amount of data in more tables, okay, joining of the table takes more time to get a report. So the joining of a table, so see, the report means your select statement. We are going to write a select statement to generate a report, right? So it takes lot of time for generating a report because of having more number of tables and more joins. That's why we will use the less number of tables, that is also denormalized tables. Don't worry about this normalized and denormalized. We are going to have a special class on the data modeling technique. We are going to have a special class over the, not this weekend, for the following weekend. Okay, so the data modeling, here we are going to have a more number of tables. Here we are going to have more number of tables. Here we are going to have the less number of tables. Those tables will be used for storing dimensional modeling. So let's now see here we are not considering the ER modeling. Okay, so the dimension in the dimensional modeling tables are divided into two types. Tables, all the tables only. Tables are divided into two types. So one is dimension table and the second one is fact table. Dimension table and fact table. So the tables are divided into two types, fact table and dimension table. So what is the meaning of the fact table and what is the meaning of a dimension table? Okay, so first let's see what the fact table contains. Okay, so the fact table, let's see. So now in the last class we have seen Walmart example. What Walmart example will do? Okay, they need to identify how many products, okay, how many products Walmart sold in 2014 Thanksgiving. How many products a Walmart stored in the 2004 Thanksgiving? Okay, so how many products Walmart sold by location? Okay, so let's see now. Yeah. Okay, so how many products Walmart sold by customer location, customer wise? Okay, you want to see the customer wise. How many products Walmart sold on 2014 November 15. So this is the Thanksgiving weekend. Let's say Friday, Saturday and Sunday. Okay, here November 25th, particular day. Okay, particular day. Location in the sense is how many they sell in the New York, how many they sold in the New Jersey, how many they sold in the, okay. So now here from these four questions, so basically what is the information we are measuring? What is the information we are measuring? What is the information we are measuring? From these 4 questions, what is the basic thing we are measuring?
Sales. Sales.
Sales. Sales are product. So this sales. So this sales. And then, okay, the sales by year 2004 and sales by location and sales by product and sales by customer, right? So we are customer, sales by sales amount. Okay, so now sales, this is the sale amount. So this is sales by year, sales by location, sales by product and sales by customer. So this sales is called as the fact. The fact means measure of the business. The fact is nothing but is the measure of your business. Measure of a business. What we are measuring. Okay. So this measures by what? This customer and this product and this location and this year. So these 4 are called as the dimensions. These are called as dimensions. So the sales by year or sales by location or sales by product or sales by customer. So these are called as a dimension. So the amount, what is the business? Okay, so the fact is the measure. Okay, so we are calling, is called as the dimension table and then a fact table. Okay, everybody is clear? Yes or no, please?
Yes.
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 Anybody have any doubts, please? Okay, we are going to measure the fact and the dimension. So the dimension table and a fact table. I'm not going more details into the dimension table and fact table. We will go this after finishing the sum of the classes. Okay, what is the fact, what is the dimension, and what is the level, what is the hierarchy, and we will see in the next week or following week. That's for the reporting side mostly. Okay, so the dimension table and a fact table. These are the fact. Basically, everything contained a dimension table and a fact table. Okay, so the dimensional modeling. So dimension model can be either star schema or snowflake schema. The star schema or snowflake schema. In the star schema, see, that means, see, the dimension modeling, it contains only 2 tables, dimension table and a fact table. Dimension table and a fact table. But what is the star schema and what is the snowflake schema? The star schema and snowflake schema. The star schema means the way we are organizing the tables. Let's see. See here. See, this is a star schema. This is the center one is the fact table. Center one is the fact table. All these surroundings by dimension tables. So this is the order number. This order number is the primary key. Customer number is a primary key in the customer table. The salesperson ID is a primary key in the salesperson. Product number, a date key, and the city name. See here, this has a 6 dimensions. In this star schema, we have a 6 dimensions. Order is a 1 dimension, and customer is a dimension, and the salesperson is a dimension, and product is a dimension, and date is a dimension, and city. So the central table is the fact table. In the fact table, we have a foreign keys to all the dimension tables. See here, order number, salesperson, customer number, product number, date key, city. And what are we measuring in this? So here we are measuring quantity and total price. So this quantity and total price are called as the fact or measure. Okay, so quantity by product, quantity by order, quantity by customer and product, quantity by city, and quantity by date, the total price by salesperson, the total price by customer, product, and date. See, we can generate the data or report in the multiple dimensions, the multiple ways. See here, I want to find a quantity by city. Generate a report using this. So I want to generate a report of total price by each product in each year in each city. So a single report in the product wise, date wise, and city wise. That's the star schema. We will design the tables, fact and dimension tables. Okay. Everybody is it clear?
Yeah.
Yes. See here, a single fact table, and for each dimension, one dimension table. So this is the fact, product, city, customer, and time. Now this is the star schema. The snowflake schema is, okay, city. In the city is again further divided into regions. So further normalized. Okay, here in this one, here in the star schema, city and the region will store in the same table. So we are not going to have a more number of tables. In the city and the region, we are storing in a same table in the star schema. But while coming to snowflake schema, city, we will separate region information into different table. So this is called as a dimensional hierarchy. So normalizing the dimension tables. What is the normalization and everything is very important, but that it comes under the data modeling class. The data modeling class, city and region. So it's a separated snowflake schema. Which schema is mostly used for the data warehouse? So the star schema, not snowflake schema. Why? In the snowflake schema, we are going to have more number of tables because the dimension tables is further divided. Dimension tables is further normalized. So more number of tables. But what is the disadvantage of this schema? So here in the city, the region information is repeated because we don't have separate table for city. So the region information stores inside the city table. That's why it's going to duplicate the data. So the star schema have a little bit of duplicated data because of denormalized. Whereas in this one, so the region information will not repeat in the city table. It has a foreign key to region table. That is called as a snowflake schema. So our aim in the ETL is to load data into these tables from your sources. So our aim, what is your aim? Aim is to load the data into this dimensional modeling technique. Everybody is clear? So this slowly changing dimensions we will see. So now here dimension tables, and so we will use ER modeling and then DWH and DSS modeling. So we can use ETL tools for loading data into OLTP systems also, or we can load the data into DWH and DSS also. Once the data is loaded into data warehouse, reports can be generated from any reporting tool. Everybody is clear of introduction of the data warehouse and architecture and the data flow? Yes or
Yes.
no, please?
Yes.
Okay.
Yeah.
Yes. So today I'm stopping here. Tomorrow we are going to start our actual tool specific one. Okay. So tomorrow we are going to have a class at 10 o'clock.
Right. Can you send the videos of these two sessions?
Yes, yes. Videos I will upload. I am in the process of uploading to the YouTube. Once I upload it, I will share to your email ID. Okay. Yeah, maybe I'll.
And one more thing, can I install SQL Server in Mac? Do you have any idea?
SQL Server in Mac, I don't think it is possible. Let me check it. Okay, SQL Server is from, I think it is not possible installing the SQL Server in the Mac. The one way is you can create a virtual machine of XP and then we can install in the XP.
So for that, I need to find